In this video, I want to introduce you to the chain rule. And the chain rule is used to differentiate composite functions. Now we know from our work with composite functions that they have an inner function and they have an outer function. And being able to recognise which one is the inner function and which one is the outer function is essential for using the chain rule. Now, a word of warning, there is a shortcut. We will get to that in a minute. But it is absolutely essential that you can use the chain rule, not just the shortcut. You need to be able to set it out correctly. So let's have a look at our composite functions and inner and outer functions. So as I said, you need to be able to identify the inner and the outer function. So the outer function is, in this case, f of x, and our inner function is g. Now, when using the chain rule, we refer to the inner function, we label it as u. And so you can see here I've got y is equal to, and that inner function here, 5x minus 4, I'm going to write that as u is equal to 5x minus 4. And then our outer function, which is that green function, becomes a function with regards to u. So it actually becomes u cubed. So with our next function that we've got here, we've got the square root of this whole function. And so this whole function is our u. And the square root of that inner function, we can write as the square root of u, which is u to the power of a half. Pause the video now and have a go at this one, and then I'll pop the answers up for you. How did you go? The overall function is that of a hyperbola, 1 over something, and the something that it's over is x cubed plus x squared. So once we know how to identify our inner function and our outer function, now we can learn to use the chain rule. So the chain rule appears on the methods formula sheet like this. dy dx is equal to dy du dx. So there's a little time sign in between here. And so to find the derivative of the composite function, we need to find the derivative of the y with respect to u and the derivative of u with respect to x. So we're going to work through with this particular function here, and you can see that our inner function is x squared plus 2x plus 1, and our outer function is u cubed. So the steps we need to do are, first, identify our inner and our outer function, and there they are there. So y is u cubed, and u is x squared plus 2x plus 1. Then the next step is to find the derivatives of the inner and the outer functions. So find the derivative of y with respect to u, which gives you dy du, and your answer will have a u in it, and then the derivative of u with respect to x, so it will be du dx, and then find the derivative of that, and it will have x's in it. Then we need to multiply the two derivatives. So if you look at your chain rule formula, dy du times du dx, okay, we're going to multiply those two values together, and so it looks like this. Now, once we multiply that together, you can see that we're going to have to substitute back in that u for the value that we've got. Okay, so the next step is substitute the inner function for u. So where the u is, I'm going to replace it back with the original inner function. So our u we've got in our formula here, and our u is this value here, not the derivative, the original function. And now we've got our derivative. Okay, now if it doesn't ask for it in a particular form, or it doesn't say for you to simplify it, this is an answer. However, in the textbook, sometimes they go on. You can see here that there's a common factor of 2 that can come out of this bracket here. And so sometimes in the book, they will simplify it down much, much further. So if I did that, I can actually simplify both brackets. And you can see now that what we're ending up with here is x plus 1 all squared and an x plus 1 here. So yeah, we're going to need to combine these things together. So let's just move this whole thing up here and have a look at what we get to do. So, next step. I've multiplied out this bracket here. Okay, so using my index laws, that gives me to the power of 4. Then what I can do is multiply my whole numbers together. So 3 times 2 gives me 6, and I have x plus 1 to the power of 5. Now, if you differentiated our original composite function with your CAS calculator, and I've done it here on the TI Inspire, this is the answer that you get. And you can see that this answer is different to this answer. And so what I did here, I used the factor command to just factor my answer. And now I've got the same answer as what I had here when I did it manually. And if you're concerned about getting through questions as quickly as possible practicing, although you should practice the algebra, you can actually put your answer that you get equal to the answer from the back of the book and press enter. And if the two answers are the same, so this one is the unsimplified version and this is the simplified version, your calculator will tell you that it's true. If it's not true, it'll just spit back the same question at you. All right, so what you're looking for is it to say true. Okay, so now let's look at a really complicated question. And this is complicated because we're going to find the derivative and we've got parameters in here. Okay, so we've got an A and we've got a B. And so the process is still exactly the same. So this is a composite function. So we need to identify the inner function and we need to identify our outer function. Then we need to find the derivative of our inner function. Now the A is just a constant. When we do the derivative, the A is a constant. So the derivative of the inner function, the 3's coming out the front, will be 3a squared plus b. And for our outer function, this n is just a number. So we still follow the same pattern. In fact, you can use your formula sheet to help you here. So the n comes out the front. We still have our u, and the power of n drops by 1. And so we then multiply our two derivatives together. Now you can see that I've put du dx first and dy du simply because it flows better. And then substituted my u in with my original equation and simplified if I could, which I couldn't. Now, let me show you the shortcut. So the shortcut for the chain rule is that you find the derivative of the inner and you times it by the derivative of the outer. Let's do an example. So y is equal to, here's our inner function and here is our outer function. So to use the shortcut, we write dy dx is equal to, and then we write the derivative of the inner function, and then multiply it by the derivative of the outer function, but instead of having a u, we leave the u written as the inner function. And then we just tidy it up. Press pause and have a go at this next example, and then I'll put the solution up for you. How did you go?